In the 121st minute of the 2022 World Cup final, Ousmane Dembélé crossed the ball. Randall Kolo Muani touched it, the net moved, France were through, then the most advanced sports technology ever built said no. Offside, by his armpit. By a margin so tiny, it was less than the width of your thumb. And the entire stadium, along with billions watching worldwide, had to accept it, because a machine had seen something no human could physically see. This wasn't just a subjective call, it was an objective measurement, a digital truth delivered in milliseconds. This is what modern football actually is, not just 22 players and a referee. It's a multi-million-dollar technology operation hiding in plain sight, inside the ball, under the pitch, behind the cameras, and in the sky above the stadium. And most fans have no idea any of it exists. Let's start with the most controversial, VAR, the video assistant referee. When a referee calls for a check, most people think someone in a room is just watching a replay. That's not what's happening. At a Champions League match, there are up to 42 cameras installed around the stadium, including specialized high-speed cameras running at 500 frames per second. These cameras are so fast they can freeze the moment a single eyelash changes direction, capturing details invisible to the naked eye. Every feed goes simultaneously to a dedicated Video Operations Center, or VOC, staffed by former referees and technology analysts. These experts use sophisticated replay systems like Dartfish VAR to quickly access, review, and analyze footage frame by frame. They can pull any angle, zoom to any pixel, and measure any distance in the stadium with millimeter accuracy, thanks to precise calibration and advanced computer vision algorithms. The VAR team is looking for clear and obvious errors in 4 match-changing situations: goals, penalty incidents, direct red cards, and mistaken identity. For factual decisions like offsides, the VAR can simply inform the on-field referee, often without the need for the referee to consult the pitch-side monitor. But even that is old technology now. At the 2022 World Cup, FIFA introduced something called semi-automated offside technology, or SAOT. And it's genuinely one of the most impressive things humans have ever built for a sport. 12 dedicated optical tracking cameras, mounted underneath the roof of the stadium, track the ball, and up to 29 individual data points on each player's body, including ankles, knees, hips, shoulders, and wrists, 50 times every single second. Every player in the match was simultaneously built as a 3-dimensional skeleton floating in the stadium's digital twin. This system, developed by Hawkeye Innovations, combined limb tracking data with artificial intelligence to provide an automated offside alert to the video match officials. The moment a pass was played, the system didn't just freeze a camera frame, it froze every skeleton, precisely identifying the exact kick point. It then drew the offside lines in 3 dimensions, projecting them onto the digital twin of the pitch. The video match officials then validated the proposed decision by manually checking the automatically selected kick point and the created offside line. This entire process delivered its verdict in an average of 25 seconds, down from 70 seconds with traditional VAR, with an accuracy margin of less than 2 centimeters. The ball itself was feeding that system. Inside the Al Rihla, the official World Cup 2022 match ball, was a tiny inertial measurement unit, or IMU. This sensor, positioned in the exact center of the ball by an Adidas suspension system, was sending its precise position, spin rate, and velocity to the stadium's servers 500 times per second via ultra-wideband radio frequencies. The ball knew where it was in space before the cameras did. When a player kicked it, the ball had already reported the exact moment of contact before a single camera had finished processing the frame. Think about that. The ball was faster than the cameras watching it, providing a crucial timestamp for offside decisions. Now here's something almost nobody knows. Goal line technology, the system that tells the referee in under a second whether the ball crossed the line. It does not use the same video feeds as VAR. Instead, systems like Hawkeye use 14 high-speed cameras positioned specifically on each goal, capturing between 340 and 500 images per second. These cameras triangulate the ball's exact 3-dimensional position 1,000 times per second using computer vision, even if only 25% of the ball is visible. The result, accurate to within 5 millimeters, lands on the referee's wristwatch, which vibrates and displays goal before the net has stopped moving. This system, first implemented at the FIFA World Cup in 2014, has never given a wrong answer in a major competition. But the technology is not just about decisions. It's about survival. Every elite player now wears a device the size of a matchbox between their shoulder blades during training and even in some matches. These GPS performance trackers from companies like Catapult Sports and Stat Sports contain a GPS unit, an accelerometer, a gyroscope, and a heart rate monitor. They record where players are on the pitch to within 30 centimeters, how fast they accelerated, how many times they sprinted, and how hard their body worked to do it, capturing up to 1,250 movements per second. Clubs call this the physical load. After every session, sports scientists and data analysts compare each player's load against their individual baseline and against the match schedule. If a player's data shows they are carrying too much fatigue, indicating a higher risk of injury, they do not play. Not because the manager decided, but because the data decided. Manchester City, Liverpool, Bayern Munich, they all have departments of sports scientists whose entire job is reading these numbers, managing player workload, and keeping players healthy and on the pitch for as long as possible. And then there's the stadium itself. The Tottenham Hotspur Stadium has a pitch that moves. The entire natural grass surface, all 7,000 square meters of it, is divided into 3 enormous sections, each weighing over 3,000 tons. These sections are mounted on hundreds of motorized wheels and rails. After a football match, the pitch splits apart and slides out from under the south stand, parking outside the stadium in the sun and fresh air. Then, an artificial turf surface slides in for NFL games, concerts, and other events. This complex system, designed by SCX, takes about 25 minutes and runs almost entirely automatically. The grass gets better treatment than most humans, with integrated grow lighting, ventilation, dehumidification, and irrigation systems ensuring optimal conditions. Modern smart stadiums contain tens of thousands of IoT sensors. At venues like the Allianz Arena in Munich or the Emirates in London, sensors monitor everything. Crowd density in real time to prevent dangerous surges, achieved by tracking foot traffic in hallways and entrances, beer tap flow rates to predict and restock demand, air quality, temperature, and humidity in every section to adjust climate control and ventilation systems, and even energy consumption for efficient facilities management. The stadium's operations team sees all of this on a live dashboard, often powered by AI and edge computing, before most fans have even found their seats, allowing for real-time adjustments and enhanced safety. The broadcast you watch at home is not the match, it's a constructed version of the match. The glowing yellow offside line you see on television does not exist in the stadium. It's generated in real time by optical tracking cameras that know every player's position, rendered by software from companies like Vizert or WT Vision, and composited onto the broadcast feed in under 200 milliseconds. This first and 10 system, first introduced in the mid-90s, was a complex engineering challenge that revolutionized how we watch football. The floating player names, the speed graphic when someone sprints, the expected goals number, all of it is computed live using real-time data integration and painted into your screen frame by frame. Spider cams, the cameras suspended on cables above the pitch, are controlled by software that can position them to within centimeters anywhere in a 3-dimensional volume over the stadium. Operators set a shot and the software flies the camera there on the cables, compensating for wind, cable sag, and momentum in real time to deliver smooth, dynamic aerial views. Even the roar of the crowd is engineered. Stadium architects now model acoustics using the same advanced software used to design concert halls. The goal is to trap and focus crowd noise down onto the pitch and away from the sky, often through enclosed bowl-like structures and reflective materials like concrete and metal. Studies have shown that acoustic pressure genuinely affects players, creating a psychological advantage for the home team. Referee decisions go in favor of the home team more often in louder stadiums. The crowd is not just atmosphere, it's leverage, and the architects designed for it deliberately, ensuring a balance between an electrifying atmosphere and clear communication for emergency systems. None of this replaces the match. The ball still needs a boot. The keeper still dives the wrong way, and the goal still makes 60,000 people lose their minds at the exact same moment. But the next time a flag goes up, a watch vibrates, or a line appears on your screen, remember what's actually happening. Dozens of cameras, hundreds of sensors, milliseconds, and a machine that sees everything before anyone in the stadium does. If this kind of everyday mystery fascinates you, subscribe to How It Actually Works for more.